So we were founded in 2002. People have different levels of familiarity with visual search. Visual search is finding things with an image, finding things with a shape, as opposed to using text. And we were the first company in the field of visual search, founded in 2002. We have 17 US and international technology patents, and so a lot of what has happened in this industry is built on the work that Jamie has done over the last many years. So, why search by shape? I'm going to run through all this pretty quickly. The reason you search by shape is very simple. There are things that you simply cannot type. This goes all the way back to 1914. Believe it or not, optical character recognition was actually invented in 1914. Pretty astonishing to think people were going back that far. That was done to aid blind people and to help them read. A system that turned letters into musical notes, and then they could hear the music and understand the words. Amazing stuff. 1931, the problem the visual search solved was locating microfilm. So there were vast amounts of microfilm. People have to scroll through it very slowly. So one created the ability to find things in a microfilm library. So the next step came in the 1960s, locating people. That visual search had to do with fingerprints and with facial recognition. We all take those things for granted today. Somebody had to start that process. So right now, facial recognition is widely used, fingerprinting, of course, widely used worldwide. And then finally, 1993, the problem that was solved was locating words in a database. Does anybody happen to remember the name of the first search engine that found words in a database in 1993? Correct, Archie. That shows how old you are. So Archie was the first time anybody had the ability to type and say, where is this thing? We take these things for granted, but there was a starting point for all of this. So the question is, how do you find things when you can't do it with a word search? And a bigger question is, why are we even talking about this today for the shipbuilding industry? It's very simple. There was a time, for example, up until 1973, when Motorola figured out how to mass produce what they called car phones, that people, up until that point, no one ever needed a car phone. Until the early 80s, nobody needed a fax machine. Until the early 90s, nobody needed a laptop. Until the 2000s, nobody needed a smartphone. We all got by without these things until the technology was there, and then we started to realize the importance of it once it's available. Visual search is at that point right now, so I'm glad that you're here and finding out about this. You can't type shape. How much time do you waste every day, every week, trying to find files in your database? You know you've made this thing, you don't want to duplicate your efforts, and yet you have no way to find it other than hoping you get the right nomenclature and that you type that shape. So, the forces driving the creation of visual search for objects. Everything we're stating from this point on for visual search has to do with objects. We're not talking fingerprints or facial recognition. That's all done. So, forces behind it. Structured versus unstructured data. So, you can do unstructured data, you can word search, find things, but when you're looking for pictures, that doesn't work. Classification, terminology, naming protocols. She's over at this desk and she calls it a flange. He's at this desk and he calls it a bracket. This guy's over at this desk and he calls it a base. They're designing almost the same thing and they're calling it by different names. That's a problem. Language limitations in the global market, very obvious. So using your tools, your PLM and ERP systems, okay, great, you've got all this data stored, but so what if you can't find it? That's where visual search comes into play. So there are three types of visual search. I'll move through the first two fairly quickly and get to the third one, because the third one is our technology. The first one is image to image. Has anybody here used Google Images? Okay, a few people have used that. So you can pull up the screen for Google Image, and then you can drag a picture of, I don't know, an umbrella on there, and it'll pull up 2.3 million pictures of umbrellas. Okay, so it uses a photograph to find a photograph. That's what we mean by image to image search. There were, when we first checked this out a couple of years ago, there were about 60 companies in this field. We looked a couple of months ago and there are now 40. I don't know if they're going out of business or they're being bought out, but there are actually fewer companies in this field than there were a couple of years ago. And by the way, Google Images references our technology. Their patent is built on ours. So we think that's pretty cool. We like to talk about it. So image to image search is good for consumer products. It takes a photograph and it finds photographs. The reason that works so well is because there are a lot of photographs of consumer products. There's a lot in the target database and there's a lot of input database. So the AI works very well, the deep learning, the system gets better and better at realizing this input photograph will find this target photograph. Those types of searches are generally to find a category. So if you want to find a purse, okay, you're going to pull up things that kind of look like this. It might be an exact match, it might not, that doesn't matter. It's finding the right category. That's the nature of image-to-image search. 3D to 3D model search. Some of you may have used something like Geolus. If you've used Team Center. Geolus is an add-on product to Team Center. It can take 3D models and find 3D models. You type in a certain amount of text, you start a 3D model, and then it will pull up similar 3D models. Very good system as far as we know. You can't get Geolus alone, as we understand. You have to be a Team Center customer to be able to use it. So there are, as we know, about 5 systems that can do this. That can take 3D and find 3D, and by that we also encompass 2D. So 3D, 2D is engineering models. And then cross-platform search. We will start with an image, start with a 2D, start with a PDF, start with 3D, and then cross-platforms and find things. That is what we're here to talk about today. That's what VizSeek does, and there's no other way to say it. We have no competition. Jamie has developed the only software on the planet that can actually do this. So, let's talk about what this can do for you. 3 types of visual search. All right, we covered all that. Image to image. Wait, how did I get it? There we go, image to image. So that's for e-commerce. Finds photos, it's a recommendation system, and it requires digital photographs as search input and as targets. This is very critical because when you get to industrial products, especially when you've got legacy systems, you've got systems that were created a long time ago, there are no photographs of these products. That's the reason why it was important to touch on this, because if you've got some kind of a bracket, some kind of an assembly that is on a ship and it's been out there for 30 or 40 years, it's very likely no one has ever taken a picture of this. Therefore, there's no photograph in the database. Therefore, you can't use image-to-image search. Does that make sense? Good. So if image-to-image, the exact match is not important. This is, you can use a photograph and it will pull up these photographs. Image-to-image actually works very well when that is the environment that you're working in. This technology has been very nicely refined. So 3D model, once again what it does, it finds models, it requires a text limiter, so you only are looking for solenoids, you're only looking for whatever it happens to be. And the exact match is important. It doesn't help if it's a different size bracket. You need an exact match. So you can use a model and it will pull up models. I'm just curious, does anybody use 3D model search? All right, a couple of minor nods. Okay, maybe a little bit. 3D also has duplicate part reports. That's one of the nice things that it can do. So you can say, have we made a part like this? Or what are we making that's duplicated effort? So you can take an input, and it's going to pull up, and you're going to go, shoot, we're making 15 of the same thing. We got 15 SKUs, we have 15 sets of tooling, we're making 15 of the same part. Is there a way that we can consolidate this? Better yet, is there a way that we can avoid doing that from this point forward? And the way that you do that, of course, is being able to search by shape. So these are all actual searches that we did. Going back to the cross-platform search, that to be able to cross-platform, take one kind of input and find another type of target. It encompasses all of those. So everything that image does, everything that 3D to 3D does, the cross-platform does. So you can find a 2D, 3D hand sketch. That actually works very nicely with hand sketches. So you're thinking, okay, we've done this before. I'm pretty sure we've made this before. You can draw one out, take a picture with a smartphone, and then our software, VizSeek, will go pull that up in your database. It can be an immense time savings, and that, of course, means greater profit margins. So, as we discussed, there are tens of millions of parts that have never been photographed, so you can't use image-to-image search. The flip side of that, so on the image-to-image side, you've got a lot of people in the field that can take a picture with their smartphone, but there's no photograph to search for in the database. No one's ever taken a picture of this industrial part. On the other side around, when the 3D models search, the ones that can only do 3D model, that's great, but nobody out in the field has a 3D model to use as input. Does that make sense? You have to have both on both ends. The cross-platform overcomes that, where you can use a photograph out in the field or on a desk, and then be able to pull up a 2D, 3D model. So the three primary applications for this: design reuse, duplicate part reports, and aftermarket parts. And I know I'm flying through this, and I appreciate everybody buckling in and sticking with me. This is a ton of information. So the cross-platform, so you can search, this is what you can do. You need to design a component for a gearbox, and of course fill in the blank of whatever it is that you have to design. So you can use a hand sketch, or you can do a quick rough on your computer. Then that is compared to the database of models, and you can find the CAD data. And then the engineer does the same as, does whatever tweaking, and now you've reused an existing design. All that work you did creating that design last year, last month, now you can capitalize on that and very quickly create a similar part by doing the same as on the model. For design reuse, the impact. We've done some studies on this, both our own, and we pulled up research that some management companies have done. So, cost of tooling per part, we didn't come up with that. That's outside data that we've used. We can provide that later if you need that. 8 to 10 weeks, tooling time. About 30% of tooling can be, if you're assuming that you've got about 30% duplicate parts, then that means 30% of your tooling can be reused. So you just avoided all that time and cost and effort and created a new SKU and everything else you have to track. So, based on those numbers, if you're doing those types, if you have 1,000 new parts a year, and there's tooling cost, 30% of units, 180 grand a year. Your mileage will vary, but these are real numbers that we have encountered over the years. And these are actually, by the way, very, very conservative numbers. We don't like to overstate the case. We prefer to understate the case. These are very conservative numbers. So, duplicate part report. Again, I put this up here, just wanted to touch. These are the three uses. You've got design reuse, duplicate part, and then the aftermarket part. So once again, just refresh me, you've seen this. So going into the aftermarket. This is kind of what it's like. The engineer needs to find a part. What is this thing? Take a picture of it. Okay, it's a propeller. Nobody here's fooled by that. Okay. The engineer takes a photo of it. The matching products along with the SKU and whatever it is that you want to pull up, okay? And by the way, it's up to you if you want this to be customer-facing or if you only want this to be internal-facing. How much information you want to reveal to the outside, or if you want to keep it all internal. You decide what information is pulled up, what metadata is returned along with that part. And, by the way, they can use a text limiter, so they can say, here's a part, what is this thing? It looks like it's got a galvanized coating on it, so you type in the word galvanized on your smartphone, take a picture of it, and now it will limit the search to galvanized parts that are in the shape. Does that make sense? So everything we deal with as far as our searches has to do with geometry. That's what we're after. We're interested in the geometry of this part. So then the correct part is ordered and shipped out to the job site. So we have a customer right now, it's a Fortune 500 company, is about to come on board. Their rough estimate right now is that VizSeek will save them 100,000 man hours a year in aftermarket parts sales. And these are not, it's not like they're going to do wholesale layoffs. They have such a backlog of aftermarket parts that this is going to free up their staff. Instead of sitting on the phone for hours or even days going back and forth trying to find an interpreter, does anyone know how to speak this language? What is this part? Email me a picture back and forth. It can take a huge amount of time to solve this problem. With VizSeek, you can solve it in seconds. Just think about what that will do to your bottom line. So for the aftermarket, we have some numbers, but I just call that out. This screen is too full. So dramatically increased turnaround time, customer satisfaction, and this is a big deal. We're talking And our clients, by the way, are big companies. We work with companies that do a lot of engineering. If somebody only has 300 parts, they don't need VizSeek. All right, they can manage that otherwise. One of the things that we're finding from the big OEMs is that they often now don't see each other as competitors. They see Amazon as their competitor. Because people can get gray market parts from Amazon. Somebody's out there reverse engineering parts, and they're buying it from other sources. When you can very quickly get that part into the customer's hand, and you know it's the right part, then you're capturing that aftermarket part business. And it's not going to third party, to gray markets and black markets. So, cross-platform. This is just kind of our laundry list of everything we do. Image to image to pull up 3D, and so on. An image, by the way, is a photograph or a hand sketch. So this is all the different types of searches that we do. It's a long list. We like to put it out because I think it's pretty cool. So, a couple of examples. You can use a PDF raster. And by the way, that's a fairly new development on our end. Being able to use PDFs as input to be able to pull up drawings. That's something that we've just finalized in the last year. So software is never done in that sense. You're always improving your software. So use a raster, and then you can pull up, using that drawing, you can find 2D raster or 3D models. Extraordinary time savings. Using a photo, VizSeek knows to take out the hand, to ignore the hand. Our software will ignore what it thinks are shadows. And because obviously on a ship, very often you've got a very messy environment. So you can't get a nice clean shot of it. And so there are ways that you can work around that. We suggest people pinch in as close as possible. We have actually developed a tool where if you've got a drawing and you've got it on a tablet, you can actually take your finger and draw a circle around the part that you're interested in, and our system will ignore everything else and only search for what's inside the circle. Or you can trace the part that you want with your finger, or on a desktop, use a mouse, and just draw a line, click, trace, and it will only search for that part that you traced. Because, of course, engineering drawings and photographs, this can all be very messy sometimes. So you can use this photograph caster, and then you can pull up photographs, 3D models, letters in a database. You can use a hand sketch. Okay, we're kind of hung up on casters, but that's all right. So you can use a hand sketch, and the hand sketch will pull up. You're probably not going to have hand sketches in your database, but it's going to pull up photographs, and it's going to pull up 2D and 3D models. So, application. For engineering and design reuse, and the duplicate parts, so those first two areas, those internal driven areas, what's it do for you? It eliminates duplicated effort and tooling, it eliminates wasted man hours. All of this goes straight to your bottom line, okay? This increases your profit margin at every step along the way. It eliminates unnecessary SKUs and part numbers that you have to track. And it promotes commonality and speed of design and development. Commonality, of course, is something that's very much in discussion in the shipbuilding industry. Pat and I have talked about this several times. So this, right now, would be internal within your database until there's some sort of industry database, which is difficult because people don't like to let go of their information and put it in a common industry database. That's a tension. We recognize that. But this will promote commonality and speed of design and development. On the aftermarket side, what it does for you, it eliminates frustrating parts or searches for replacement parts, wasted man hours, and supply depots, and it gets broken down equipment back into service much, much faster. So it promotes speed of repair and replacement. So I'm going to wrap up here and allow some time, but once again, we are Imaginestics. And we are in Purdue Research Park in West Lafayette, Indiana, which is difficult for me because I'm an Indiana University guy. And Purdue is our arch rival. And so I have a son at Purdue. So after 4 years, I can say, go Boyle. That's as far as I can get. I'm working on the rest of it. So our system that we talked about today, VizSeek, are two that are almost finished. AMA in development with the Air Force. We did a 2-year project with them for the additive manufacturing, project management, and SQA, which will be ready about the end of this year. So, new technology, and I'll leave this up here for now.